Welcome to The Explainer. Today, we are going to tackle one of algebra's trickiest topics. Yep, absolute value. And we're going to flip it on its head, turning all that confusion into something you can actually see and, just get. So let's kick things off with a little bit of a puzzle. What in the world did these things have in common? They seem totally random, right? But believe it or not, they're all governed by the exact same mathematical idea. And that answer is, you guessed it, absolute value. But this isn't just some abstract thing from a textbook. No, it's the language we use every single day to define the acceptable ranges and boundaries that just make our world work. Think about it. The thermostat in your room, it's keeping things comfortable by staying close to a target temperature. The parts in your car have to be almost exactly the right size, with just a tiny bit of wiggle room. All these acceptable ranges, they're all defined by absolute value. But let's be real for a second. For so many people, learning this stuff feels like you're just trying to memorize a ton of disconnected, super confusing rules. This quote from a student on Reddit, man, it just perfectly captures that feeling of frustration. Okay, so we're going to do something radical. We're going to throw out that whole way of thinking. Forget memorizing all those rules. We're going to focus on one single, simple idea that makes everything, and I mean everything, just click into place. And that big, powerful idea is distance. That's it. Once you start thinking about absolute value as just a simple way to measure distance, all that confusion just starts to melt away. Seriously, this is all it is. When you see those two little bars around a number, like absolute value of x, the only question you have to ask yourself is, how far away is this thing from 0? That's it. Both 5 and -5 are 5 steps from 0, right? So their absolute value is just 5. Distance is always positive. So, how does this whole distance idea actually help us solve problems? Well, let's put it to the test. We'll start with some basic equations, and then we'll get into the really tricky stuff, inequalities. Okay, so here's the game plan, and it works every single time. First, you've got to get the absolute value part all by itself on one side. Then, you just look at the number it's equal to. That number is the key. It tells you exactly what to do next. And here's the cool part. Every single equation you'll ever see will fall into one of just 3 categories. And it all goes back to our big idea, distance. If the distance is a positive number, well, there are going to be 2 spots on the number line that work. If the distance is 0, there's only one possible spot, 0 itself. And if you're asked to find a negative distance, can distance be negative? Nope. So there's no solution. It's that simple. All right, you ready? Now we're diving into the main event, inequalities. This is where thinking about absolute value as distance goes from being kind of helpful to being an absolute game changer. It turns out there are really only 2 kinds of absolute value inequalities, and they both come down to a really simple question. Are we looking for numbers that are close to 0 or far from 0? Less than problems want everything that's close, all bundled up in a single interval. But greater than problems, they want everything that's far away, splitting off in opposite directions. Let's check out a less than problem. What this is really asking is find all the numbers where the expression 4x minus 1 has a distance from 0 that's 3 or less. That means it has to be trapped, or kind of sandwiched, right there between -3 and +3. So to solve it, we literally build that sandwich. You just write a 3-part inequality, stick your expression in the middle, and then solve for x. And the rule is simple. Whatever you do to the middle, you've got to do to both ends too. Now, what about greater than? This time we're looking for values whose distance from 0 is 3 or more. These numbers aren't trapped in the middle. Oh no, they're the ones way out on the edges of the number line, far from the center. See, because the answers are in 2 completely separate places, you can't solve it all at once. You have to split it. You make 2 separate problems. One where the expression is greater than or equal to 3, and another where it's less than or equal to -3. Solve each one on its own, and you'll get your 2 separate solution sets. Okay, now that we've got the main strategies down, let's talk about the most common mistakes people make. Knowing what these traps look like ahead of time, that's the real secret to acing these problems every single time. All right, listen up, because this is, without a doubt, the #1 mistake in all of algebra. I'm serious. If you multiply or divide an inequality by a negative number, you have to flip the sign. Burn it into your brain. Forgetting to do this will get you the wrong answer, guaranteed. Now this quote here, it points to a massive shortcut. Before you just jump in and start doing a bunch of algebra, you should always pause and think, what does absolute value actually mean? This is a huge pro tip. If you get the absolute value by itself and you see it's being compared to a negative number, just stop. If it says the absolute value is less than a negative, that's impossible. The answer is no solution. And if it says the absolute value is greater than a negative, well, yeah, it's always going to be positive, so that's always true. The answer is all real numbers. Don't let these traps waste your time. So let's bring this all back home. We started out with some real-world problems, we dove deep into the math, and now we can finally connect it all together using our new distance way of thinking. Remember that manufacturing problem from the beginning? A part needs to be 20 millimeters, but it's okay if it's off by no more than 2 millimeters. Now look at that inequality. It's saying the distance between the actual dimension, d, and the target, 20, must be less than or equal to the allowed error, 2. It's a close to problem, a sandwich problem. And that's exactly why thinking in terms of distance is so incredibly powerful. When you can read the math like it's a sentence about distance, it just stops being abstract symbols on a page. It becomes a perfect, common-sense description of what's actually happening. So, at the end of the day, absolute value isn't just some random chapter in a math book. It's a way of describing the boundaries that shape our world. And once you really learn to see it as distance, you're going to start noticing those boundaries in science, in engineering, even in your own life, absolutely everywhere.